Okay, in this video I'm going to go over how to factor trinomials, and I'm going to go over how to factor a particular kind of trinomial. Now, if you watched my other video, my introduction to factoring trinomials, I said there are basically 4 questions that you need to ask yourself, and you need to go through this procedure over and over and over again whenever you see a trinomial, okay? And you should do it in this order, or at least do this one first, and then it really doesn't make any difference afterwards, which are the next 3 questions you ask. But definitely do the first question first. And you always ask yourself, are there any common factors in each of the terms of the trinomial? And again, if there are, you pull them out. We'll do a video on that one. We're going to do in this particular one, this second question. Does the leading term have a coefficient of 1? Remember what that means. You look at the first term. So let me just highlight that real quick. You look at the first term and see if there's a number in front of the variable. And if there's no number, then the number is 1. It's just understood to be there. And there's a way you have to factor that. Then finally, the other 2 questions that you should look at or try to recognize is, does the leading term have a coefficient other than 1? That's easy enough. This method is actually called the bottoms-up method. And I've got videos posted on that already, so you can check those out. And then finally, is the trinomial a perfect square trinomial? And again, I have a video posted on that one. But we're going to focus on this second one here. Does the leading term have a coefficient of 1? So let's look at an example of that. So, trinomial, it's a quadratic trinomial because it has a square in the front. But again, the leading coefficient is 1, isn't it? And this is what you do. If it's got a 1, you go immediately to the constant. And you do what's called pair factoring on the constant. So if it's 10, you start writing down all the pairs of factors that give you 10. Remember, factors are numbers that you multiply to get 10. So you start with 1 times 10. You can see that there's no combination whether that's a plus or a minus that will give you -7. 2 times 5. Oh, wait a minute. That looks like it might be. Okay? So 2 times 5 is +10. But they add up to +7. And that's what you have to do. Once you find the factors, you add them up to see if you got the middle term. But notice this. If I said -2 times -5, I still get +10, but now I get to add up to a middle term of -7. Those are the factors you want to use. So what you do is you write down 2 spaces, 2 binomials, and you go plus and minus. Always start off that way. Always, for all of these, plus and minus. And then you just put the 2 factors in there. So -2 and -5. So I need to basically change that to a negative. There we go. And then you just take the square root of the leading term, so x and x. So you get for an answer x minus 5, x minus 2. Okay? Now, how do you check it to make sure you got the right answer? You do a multiplication. Now, I just do this little technique called a smiling face. Okay? It looks like it's a smiling face. You just connect the first and the last one, and then you connect the 2 middle ones. And you multiply them. X times -2 is -2x. -5 times x is -5x. Add that up, and look what you get. -7x, and it matches the middle term. So you know that this is actually correct. This is just a way of checking your answer. Okay, let's try the next example here. So I've got a leading coefficient of 1, so that's already taken care of. So again, just like before, I go immediately to the constant, -21, and I start writing down all the pairs to see if I can add up to a -4. So what is it? 1 times 21, 2 doesn't go in, 3 times 7. Now that looks kind of promising, doesn't it? So if I made the 7 negative and the 3 positive, I would get -21 when I multiplied, but I would get a -4 when I added them. Sure enough, it passes that test. So again, go ahead and write your 2 binomials. Now, notice I said you had to do plus and minus. That was actually a little bit incorrect. You just take the signs of whatever your factors are. So we're going to say +3 and then -7. All right. Take the square root of the leading term, and again, you've got your answer. Again, let's check by doing the smiling face. X times negative 7 is negative 7x. 3 times x is 3x. Add them up, you get negative 4x. And again, it matches the middle term. So you've done it correctly again. Okay, let's just do one more in this set and see what we can come up with. So x squared plus 12x plus 48. Let's see what that does. So again, I got a leading term of 1, so I'm good there. Let's go ahead and pair factor 48, and let's see if we can add up to 12. So I start with 1 times 48. Okay, that doesn't clearly add up to 12, no combination. 2 times 24, again, no combination, pluses and minuses can get me to 12. 3 times 16, now I'm getting close, right? Because if that were positive and that were negative, I would get negative, what, positive 13? But again, that's not quite right. Let's go to 4 times 12. No combination gives me 12. 5 doesn't go. 6 times 8. Again, it adds up to either 2 or 14. So no, that's not going to work. 7 doesn't go. And then finally, 8 times 6 was really just a repeat of 6 times 8 because of the commutative property where you can flip numbers. And again, it doesn't go. So what am I concluding here? These are all the possible pairs of 48, but none of them add up to the middle term of 12. This is a prime trinomial. Now don't be afraid to call something prime. If it can't factor, it doesn't work. Okay? And that means basically that it cannot be factored further. Okay, so I hope that was helpful. Again, remember that you always check to see if the leading term is 1. If it is, go to the constant, start doing all the pairs that add up, pairs of factors that add up to the middle term. You can do that check with a smiling face. That's just a quick way of doing it. All right, I hope that was helpful for you.